Hello, how are y'all doing today? Today we're working on LeetCode 101, Symmetric Tree. We're given a root of a binary tree, and we need to check if the tree is a mirror of itself going from the inside out. This isn't a search tree, so we can have any value for a given node. Also, please use timestamps in the description to jump to the parts in the video you actually want to see. Alright, let's take a look at a couple examples and talk about this problem. Let's start off by talking about what makes a symmetrical tree. A symmetrical tree means, in this case, that the nodes starting from the inside have the same value. If there are more than one pair on a certain level, you'll move outward from the middle by a node pair. What this looks like is this. This tree has a 4 and 4 in the middle, and we move outward to 3 and 3, and those values match as well. On the final row, we can see this a bit better. We start in the middle, and both of them are null, and then we work our way out, and every single pair is null, so they all match with each other. So this tree would be symmetrical. Now let's contrast it with this tree. You can immediately see that the nodes on the third level in the middle are not the same, so by our rules, this tree is not symmetrical. Okay, let's talk about solving this. So we'll start with smaller trees and work our way up to larger examples. Alright, so we're going to start off with just the root and then the left and the right being null. Alright, so let's talk about this. The way we find out a tree is symmetrical is if the root left is equal to the root right. In this example, we see that the root left is null and the root right is null, so the tree is symmetrical. Easy enough. Adding another level to this tree, things get a bit more complex. We now have tree nodes on both the left and the right. So we need to compare this tree node's left with this tree node's right, and then switch so that we compare this right with this left. And this is the whole algorithm. You compare a node's left and right with the opposite sides right and left. This way we satisfy that condition of these specific node pairs having equal values. Adding the third level might make it seem more intimidating, but it's the same idea. Starting at the root, we compare the values of its children. Their values are equal, so let's look at their children. We'll, as always, start by comparing the left and right nodes. These nodes have the same value, so now we'll look at their children. Again, we start by comparing the left to the right. Okay, we've finally gotten somewhere. When we hit null, we know we're at the end of a branch, and since both values are the same, we know this part of the tree is symmetrical. Now we'll compare the other children for these nodes. Again, both of them are null, so this part of the tree is also symmetrical. These squares will represent what portion of the tree we know are symmetrical. We're now back to the root's direct children. Their left and right children are symmetrical. Now we will compare the other side. 4 and 4 are the same value, so let's compare the left to the right. They're both null, so let's compare the right to the left. These values also match, which means this portion of the tree is symmetrical. This means the root's children are symmetrical and therefore the whole tree is. Please feel free to refer back to this once we've written the code. The first thing that we're going to do is create a helper function, and it'll take two nodes called n1 and n2. We'll start by asking a couple of questions. Are both nodes null? If yes, then we'll return true because that means we've hit the end of a branch on both sides. We'll then ask, is only one node null? If this is true, we'll then return false because one side of the tree is at the end of its branch while the other isn't. We'll now compare the values of the nodes. If they're the same, we can compare their children. If not, return false. We'll compare node 1's left with node 2's right, and then compare node 1's right with node 2's left. Both of these are true, we'll return true. Lastly, we'll return the result of the compare function and give it the roots left and right. Let's go ahead and submit this. Alright, cool. If you found this helpful, please leave a like and subscribe. If you have any suggestions or feedback, leave a comment below, and I'll see you in the next video.